u and v, continuously differentiable function. We always have integral udv is equal uv minus v du. The formula here is said to be integration by parts. Integration by parts. For simply story, okay, I think you know the d, okay, d is always therefore d prime dx dv is equals v prime dx, okay? We can replace du and dv by dx, okay? We can derive integration by parts, the formula here, by integral u v prime dx is equal uv minus integral v u prime dx. Okay, I think you know the formula here. Now, let me give you an example. We need to estimate the integral natural logarithm dx. Okay, we denote the integral here by i's. You want to estimate the integral natural logarithm dx. In this example, we use integration by parts to evaluate the integral. Of course, if you want to analyze integration by parts, we need to choose u and v approaches. What's u and what's v? Now, we return to the example here. In this example, we can take the u is equal natural log x. V prime is equal 1. Okay? Is that we express the integral here by this form? U v prime dx. Apply integration by parts, we can derive. You can derive I by, okay, of course, I think you know the e prime is equal 1 over x, v. Okay, is it here v prime equal 1? I think you can estimate v equal x. Okay, equal x. Equal here is equal uv minus integral u prime v dx, okay, is equal uv x natural log x minus integral e prime 1 over x v x dx. Okay, we can reduce x natural log x minus integral 1 dx. Okay, the integral here belongs to basic table. So we can find the integral here equal f natural x minus x plus. Okay, here we have 6. Okay, we have the question. What's integral? We can use integration by parts. What integral? Now, based on the formula here, you can see the k, we can use integration by parts. Now, let's see, attention. U equal natural logarithm U complicated function. Okay? When we take derivative, U prime is equal 1 over the simpler function. Okay? So the k we can use integration by part. This may be ill complicated, imprime simpler. Okay, you can use that. Now, one function. This may be ill long range function. Okay, when you take derivative, it becomes the simpler function. Ill polynomial. Okay, if ill polynomial of degree n, when you take derivative, e prime, it becomes polynomial of degree n minus 1. Okay, degree 1 unit. Okay, e prime simpler. Okay, from the idea, what integral we can use? We can use integration by parts. Okay, I think we can take those. We can take those. Second, we can use integration by parts. If the integral it belongs this form, you can choose. Okay, it is here in this to the Vietnamese slide. Choose. Okay, choose. Okay, if you need to write out. Now, continue. You do the different example. Okay, now, evaluate the integral in example form. Example form. Integral s exponent minus 2x dx. You want to evaluate the integral. Integral in example form. Based on the table related to the K, you can use integration by part. You can choose and V of Gaussian. The integral in example form, it belongs to Kx. Okay, you can see it belongs to Kx. Okay, it's way on the table here. You can choose the U and V of Gaussian. Now, example 4. Example 4. X exponent minus 2x. Okay? In this case, you can choose equal x. V equal exponent minus 2x. From here, you can estimate E prime equal 1. V is equal exponent minus 2x over minus 2. Okay? We can replace U and V. Okay, is equal U times this x times the exponent minus 2x over 2 minus integral d prime times v exponent minus 2x over 2 dx. Yes. So continue, we reduce the formula here, plus integral, that's 3, 1 over 2 integral exponent minus 2x dx. Okay, I think the integral here we can add the rest. Integral exponent kx dx. Okay, k is not 0. We can estimate the integral here is equal of k plus c. Okay, I think you know the solid. Okay, so finally we obtain the final result. X exponent of 2 plus, okay, minus 1 over 4 exponent minus 2x plus c. Okay, we feed 5 z integral. Now, continue. We want to estimate the integral in example 6. Of course, the integral in example 6 don't belong to the table now. But we can do integration by part again, as always did. Okay, I think you can apply the integration by part in the state. The result you can obtain. You can obtain. The sum integral you can apply integration by part. The part of result you can have. Okay, I think you can use the result here to do the exercise yourself. Yes, I think you should take note. Some special integral we can use to do the exercise.
Cái này cũng thích trang nhanh thôi. Xong rồi nó còn cái thôi. Để mày được làm sao nữa. Xong rồi mày sẽ em mà ai quen.
Okay, now continue. Let me give you a different example. I want you to estimate the integral exponential side and there. Okay, I think the integral here is not easy. You can see the function we belong to integral here has the exponent and sign. When we take derivative, when we take the derivative, exponent, it becomes exponent. Sign, it becomes cosine. Okay? Cosine, when we take integration by parts, okay, it becomes sine. Okay. Does that mean the example here is not easy? Because when we integrate by parts, the function u and u prime is not singular. It's not singular. But the integral here, we still apply integration by parts. We use reduction. We use reduction and integration by parts is a integral here, it becomes equation. You can activate the eyes. Reduction. Does that mean the integral here, we can use integration by parts twice. 2 times. Twice. 2 lần. Chúng ta dùng tích phân 2 lần. Thì bằng cách truy hồi induction thì phương trình này tích phân này sẽ trở thành một phương trình và ta có thể tìm được y. Ok. Rồi. Use integration by parts. Help me estimate the integral. combining integration bypass and induction. If the merger integrals here, it becomes the equation have a variable I, you can activate I. You can use integration bypass twice.
Đấy thì sự điện thoại. Mày làm sao hai người này? Hai người này tao nói chuyện với em mà bây giờ biết phương thì được rồi.
Okay. Now, in your first integration bypass, we choose U equal exponent. V prime equals sin x. Okay, here we can imply V prime is equal exponent. V is equal minus cosine x. Okay, I think we apply integration bypass in that case. We obtain the I is equal U times V minus exponent x cosine x. Okay, minus integral E prime times V. Okay, we change the plus exponent x cosine x cosine x dx. Okay, now continue. The integral. We apply integration bypass again. We take the U is equal exponent x. V prime is equal cosine x. Okay, we have the U prime equal exponent. V is equal sin x. Okay, I think we evaluate the second integral is equal minus exponent x cosine x plus mu and v exponent x sin x minus integral exponent x sin x dx. Now you see the last integral I. Okay. So the equation here, it becomes the equation for I is equal the first factor minus I. So I is equal the function here over 2. Hence, I is equal minus exponent x cosine x plus exponent x sin x over 2 plus c. Okay, I is into the indefinite integral, so we have equation c. Okay, this here we use integration bypass to activate some integral. Okay. If you follow the example here, we can estimate the integral hedging form exponent a cosine and sine bx plus c. Okay, bx cosine intercept. Okay. Follow the example here. We can estimate the integral hedging form. The same. We can use integration by parts and deduction. Okay? It's a much integral here it becomes equation variable integral. Okay? So similar, we can estimate. Tương tự cách làm của ví dụ vừa rồi thì các bạn có thể là cái tích phân có dạng như này, e mũ nhân với hàm sinh hoặc hàm cos, chúng ta để có thể dùng tích phân thành phần integration by parts và induction retrieval để làm. Okay, I think we take a break.